Chapter 6, Section 1, so we're going to look at law of sines. So oblique triangles are triangles with no right angles. To solve oblique triangles, we need one side and two more things. So we have to have a side. And then you need two more of anything, combinations of angles and sides. Now the words to solve, what does that mean? To solve, you gotta know it means to find all angle and side measures. So that's what it means when we say to solve a triangle. The possible cases we have for one side and two more pieces of information, we could have two angles and one side. And so we have two options. We could have the angle side, or we could have the angle side angle. And so there are two possibilities when we have two angles and one side. We could have two sides and an opposite angle, and that would be side angle. We could have three sides, and we could have two sides and any angle between, which is side angle side. For these first two cases, this is law of sine, and the bottom here is law of cosine. And how to tell that in a drawing is if you're looking at these top two cases, if we're marking it. So we have angle, side, and that's what this one right here is, angle, side. Notice how we have an angle and the side opposite. That's always going to be the case for the law of sine problems. Here is law of sine. It's the ratio of a side A over the sine of angle A, and then that same ratio between the side and the opposite angle. So you can kind of see the two types of drawings. Either it's like an obtuse triangle here, or an acute, where you have the A, B, and C, where the small a is the side, the capital A is the angle. These ratios are the same, and it doesn't matter if you write the reciprocal of those as well, it's still equivalent. And so case one, let's look at this triangle here. I draw a triangle. So this one, if we set up our ratios, we could say that the 32 over the sine of 30 equals B over the sine of B, and then C over the sine of C. Oop, I put B in there. We know B is 45. So we know that's 45. We could do some quick math and say the 30 plus 45 and then subtract that amount from 180 to find our third angle is 105. So then we know that 105 degrees is angle C. It's actually an obtuse triangle. So then we can find our cross products. Now, some students will say fish method or just cross multiply and just do it in their head, but I want to make sure you understand the cross product. So if I take these two fractions, you're only allowed to cross multiply when you have two single fractions equal to each other. And when you cross multiply, it's the two diagonals. So like B times the sine of 30 equals the other diagonal, 32 sine 45. This is also called the means and extremes property. So then you divide by sine 30 to both sides, and then you can evaluate it. This is kind of a nice one actually, because you should know sine of 45 is root 2 over 2, and sine of 30 is 1/2. So then you can evaluate that a little bit. Now, we will put that in the calculator to find an approximate value for these, but I do like showing how we can still pull back our old trig to find some of these values. So we get 45.25 feet for B. And then C, we've done similar. Now I found B, but this is an approximate answer. I did not write the exact answer, so it's approximate. So I would not use that ratio to find C. I would go back and use the 32 over sine 30 and set that one equal to C over sine 105 to find C. And if you did that, you'll find C is 61.82 feet for little c. And so then we have all three of the sides. So we have C, B, and we are given A. And then we have the three angles, A, B, and then we found C to be 105. Another one, so we have side angle. So I already drew this out. And we have an angle, the side opposite in that same kind of setup, and the other side I know I like to put in this spot. And this is my personal preference. If you like a different setup, then use your method and it still works. Realize though that this is going to be the altitude or the height of our triangle, Yours may be different if you've rearranged these letters or numbers in your drawing. So then we can write that 12 over sine 31 equals 5 over sine b. And I can use just these two to find b first. So this is going to be 5 times sine 31 equals 12 times sine b. So we can divide both by 12. And so I get 5 sine 31 over 12 equals sine b. Now how do I find b from here? Well, that's using our knowledge from chapter 4. You do the inverse sine of this mess. So the inverse sine to both sides. So the inverse sine of this fraction. And so you want to be precise. And so I leave it as a fraction, not the decimal form, unless you've included the entire decimal, like held that value on your calculator. If you did that, you should find b here is 12.39 degrees. So that's 12.39. And then we could find c, and c doing the same thing. For c, if you just subtract the two angles, 31 and 12.39 from 180, you'll find c is 136.61. And then if you cross multiply, you find c is 16.01 inches. And so that's solving using side-side angle the easy way. But when we call this, and if I rearrange this, this is that naughty word, the bad word. The bad word here, whenever you say that, you need to realize that this is a pain. It really is a pain in the blank, because you need to do more things for this triangle. This triangle is a special triangle. Whenever you have a side-side angle, you have to find height. You have to have a thought process about this. So to find this height, and I'll talk about it in this one, and we'll find it for the next one, you'll see why. Our height here is this right triangle. How do you find the height of the right triangle? Using the given information of this angle and the hypotenuse when you're trying to find the opposite. To find it, it's like the sine of 31 equals the opposite over the hypotenuse. So you multiply both sides by 5, and you'll find what the height actually is. And so that's how you find the height, and you're going to need to do it for all of these triangles. So this is called the ambiguous case. Whenever you have the side-side angle, it's a pain, so you have to go through some extra information about the ambiguous case. Ambiguous means it's unknown. We're not sure what the result will be. So given that A is the acute angle, and you also know the small a is the other side, you want to compare them. So if I draw my normal setup, I'm always putting the angle I know here, so we're calling that A in this picture, and then the side I know here, and then the other side B, and then we have our height. So we're comparing it, our A to H to B, if it's set up like this. Now realize that the given information may not be angle A and side A. So if A is less than H, it's no triangle. That's the one we just had. If A is equivalent to H, it's one triangle. It's actually a right triangle. It's a right triangle. If A is greater than B, so if A is bigger than B, the other side, then I know it's one triangle. And that's actually the case we had 2 problems ago, the second example. And then if A is between H and B, so if the value of A is between H and B, then I can draw between H and B. And that gives us 2 triangles. So we have I can draw it between H and B. So this segment and this segment are both going to be A. They both have a measure that can be placed at either spot. So we have 2 triangles then. We end up with the blue triangle here, which is an obtuse angle right here, or you have the red triangle, the one we originally see here draw. And so we get the obtuse and the acute angle. That's the 2 triangles. If A is obtuse, it's a little easier because we know that we already have our obtuse angle, so other ones have to be acute to make the 180. So either we have no triangle or one triangle, and so you can check those pretty easy. The no triangles, you'll get the error when you're trying to solve it. So that's another way of seeing the no triangles. Okay, so the hard example for the side angle, the one that's a pain. So after I draw it, before I put in the letters, I'm putting the angles. So actually, let me change these letters. Let me call this C, this little c, and I'll still call that B. So I'm doing that on purpose because I want you to realize that when you're putting them in your drawing, I don't label it ABC right away. I look at the angle. So I know my angle 58. I know my side 4.5. And then the other side I know is 5. So I always put them in this position, and then I can go back and label them. So this would be C, C, big B, big A, little a. So then I'll go back and label the triangle to how I drew it. Since it is the side angle, I need to find the altitude or height. So here is my height. So I had my wife. She doesn't want to sky. So here's our right triangle. Here's a height. So we're going to do 5 times the sine of 58. And if you do that, you'll find a value of 4.24. So we have our height of 4.24. So now I can compare the sides to the height. So this side, our original side, compared to our altitude and the other given side, is between those two values. So since 4.5 is between 4.24 and 5, I can draw in there between the two. So I actually have another triangle right here where these are the same measure. And so let me draw that as a separate triangle over here. So you still have the side length of 4.5, 5, and then 58 degrees. And so those are 3 given pieces of information for the obtuse triangle, and we still have the 3 given pieces of information for the black triangle, and now we have to find the information for both of those, solve them. And so for the black triangle, we can use the law of sines and set that up like usual. So it's going to be 4.5 over sine 58 equals 5 over sine B. You can cross multiply like normal. You'll find your B value is, we get 70.44 for angle B. Then we can go through and find our angle A and our little a using law of sines. And you'll find that A is 51.56 and little a is 4.156, I believe. And so those will be the measures using law of sines. Then we have our second triangle here, up here in blue. So second triangle. So I have it up here drawn in here. We need to figure out how to find our obtuse angle right here, which in the drawing is right here. So this is kind of like B2 right here. And so if we look at the two sides here that I marked, these are both side C and side C are the same. Since those two sides are the same, then the angles opposite them also are equivalent. So these two angles are equivalent. And since B2 and this angle are a linear pair or supplementary angles, then B2 and B are also going to be supplementary. So to find our B2 value for the second triangle, it's found by doing 180 minus the 70.44, and we get the 109.56. So there's our angle B. Angle B is 109.56 degrees for the second triangle. Now that we have that, now we can just use this angle and the original 4.5 sine 58 to use the law of sines to find our big A and little a. And so big A is just going to be 12.44, and then little a using law of sines would give you 1.143. And you have to do the cross multiplying law of sines to find that. Area, these are just the formulas for area if you're given side. So if we have side, angle, side is really what we're talking about here. Then you can use these formulas to find the area of a triangle. And I'm not going to go through this one. It's just plug and chug. So plug in the two sides and the angle you know, and then you evaluate it to find the area. Make sure you include your units squared when you evaluate it. Call that good. See you tomorrow.